Hello, my name is Fahiezul. In this video, I will present my final year project, which is the critical review on the pineapple peel as the potential biosolvent for the removal of heavy metal from an aqueous solution. As we all aware, heavy metals' existence in the environment can cause health problems to the society and may pollute the ecosystem nearby. D. Bulgario said that the heavy metals exist in the river due to the industrial discharge and domestic activities. It shows a contamination sign, and this can be a threat to the environment along with public health. One of the examples of heavy metals is lead, and lead is a highly toxic metal whose widespread use that cause extensive environmental contamination and health problems. The process of removing heavy metals has been studied for a decade, where they have found ways to solve this problem. However, most of the ways come with repercussions. Conventional treatment can help to remove the existence of heavy metals in the wastewater. However, for example, reverse osmosis and chemical precipitation, this method was expensive process and will generate a chemical sludge. Nowadays, researchers concentrate more on natural waste product that has the potential to be used as an adsorbent to remove heavy metals. Hence, biosorption was introduced. This process is defined as the property of certain types of inactive, non-living microbial biomass that bind and concentrate heavy metals from the very dilute aqueous solutions. The advantages for the biosorption process over the conventional method: this process can reduce a chemical sludge, high efficiency, ability to recover metal, regeneration of biosolvent, no additional nutrient required, and low operating costs. In general, this project was conducted to study and review the potential of pineapple peel to be used as the biosolvent for the removal of heavy metal, especially lead, and to analyze the factor that can be affecting the adsorption capacity or adsorption activity during the process. The objective for this research is to study the morphology of untreated and treated pineapple peel, to study the relation between the solution pH and the adsorption capacity for treated pineapple peel, and to study the effect of the adsorption capacity with different amount of biomass used. Moving on to the methodology, all the procedure included in this section was reviewed from previous researcher that focusing on the similar aspect. Firstly, the preparation of pineapple peel treatment. There are several ways when treating an agricultural waste into biosolvent, which includes pyrolysis to produce activated carbon, chemical modification, physical modification, and cell modification. Different methods was used by researchers. However, most of the treatment method focusing on the chemical modification. Based on the studies performed by XHU, it mentioned as a result of the NaOH and isopropyl alcohol treatments, hemicellulose, lignin, and pectin components were extracted and removed from pineapple plant fiber. A. Ahmad and Yusuf used KMNO4 and H2SO4 to chemically activate the pineapple peel. The step for the preparation of the pineapple peel generally involves the process of collecting the agricultural waste, washing the pineapple peel with distilled water, multiple drying process, and grinding. Fourier transform infrared spectroscopy, commonly known as FTIR analysis, is a technique for identifying organic, polymeric, and inorganic materials. Based on previous study, all prepared samples, including raw pineapple peel fiber, will be characterized by the FTIR. The scanning electron microscope (SEM) analysis will give a wide range of information from the sample surface, but with high resolution and a considerably wider energy range. This technology was used to study the changes on the surface morphology of the raw and chemically treated pineapple peel. The standard procedures to prepare the reagent involve the dissolving of heavy metal into a certain amount of distilled water, and through a proper dilution, the desired amount of concentration can be obtained. The method of preparing specific heavy metal stock solution was seen to be similar amongst researchers, and Solidum J.N prepared the reagent by dissolving desired quantity of lead salts in distilled water. Next is the determination of the optimum pH or dosage procedure. Various ranges were used to determine the optimum pH as same as the dosage. Based on both tables below, these are the list of range that has been used by other researchers that study the effect of pH and dosage on the absorption capacity to remove heavy metals. Moving on to the result and discussion, this section reviews the expected result on the characterization of raw and chemically treated pineapple peel, effect of metals of solution pH, and the dosage influence on the absorption capacity and percentage removal of lead ions. The FTIR analysis used to determine the existence of functional group on the surface of pineapple peel sample. The FTIR spectra show a difference between the treated pineapple peel and raw pineapple peel, where the treated pineapple peel results in a new sharp band on the spectra. The new sharp band might appear due to the CH stretching. Eventually, a strong peak will be discovered, and this mainly due to the treatment effect on the CO bond of the carboxylic group. Several other stretching can be seen if we compare the treated pineapple peel and raw pineapple peel spectra. The emergence of a new peak and shift in the absorption band of the FTIR spectrum revealed that the pineapple peel was successfully modified. Both figures shows the finding made by X Hu and A Ahmad. From this figure, we can see it is showing that OH and NH stretching was identified by the analysis, and some new peak even exists indicates the chemical modification successfully implemented the functional group onto the surface of the biosolvent that actually will enhance the absorption capacity. The SEM analysis was done to study the surface morphology for both treated and raw pineapple peel. This figure shows the result obtained by A. Ahmad, and the study reported that the analysis result for raw pineapple peel shows the surface is coarse and has creases. This condition of surface has a low chance to trap the heavy metals ion. On the other hand, treated pineapple peel show there is a cave-like and porous surface, and this might be due to the removal of unwanted substances on the surface of the pineapple peel after being treated. The results from these two different conditions of pineapple peel are distinct enough and the absorption capacity will be affected. Next, this is the result reviewed for the effect of pH onto the bioabsorption capacity. The absorption of lead ion onto both chemically treated and raw pineapple peel showing a similar trend, where the absorption capacity was expected to increase significantly with the pH of the solution. At the low pH solution, the absorption of lead ion is low due to the ionic competition between protons and metallic cations, while at the higher pH of solution, the absorption capacity decreases. This might be due to the formation of hydroxyl complexes and the precipitation of metal hydroxide. X. Hu studied the effect of absorption of lead ions on a chemically treated pineapple peel. In this analysis, as the pH value increases, the absorption capacity will be increased and stop at one point, and the absorption ability was found to be poor at pH values below 4. This may be due to the protonation of the adsorbent of the active sites and the competition between the metal ions and hydrogen plus. The modified pineapple peel fiber was found to exhibit the maximum adsorption for lead ion at pH 4. A. Ahmad studied the bioabsorption of heavy metals by using a pineapple fruit peel that chemically activated using H2SO4 and KMNO4, reported that due to the obvious production of hydroxylated complexes of lead ion and the lack of free metal ions for bioabsorption, lead ion bioabsorption reduces as the pH of the solution rises. As a result, metal ion removal reduces, and the ideal pH was discovered to be in the range of pH 4 to 5. Lastly, this is the reviewed result for the effect of bioabsorbent dosage onto bioabsorption capacity. As the amount of bioabsorbent use increases, the removal percentages of lead ion will be increased. Several researchers reported the same trend. This may be due to the greater number of adsorption sites available, where the region of the surface where lead ions may bind to the surface is increased. On the other hand, maximum adsorption capacities might be decreasing as the dosage continue increase due to the overlapping of bioabsorbent surface sites where it can decreases the surface area. Similar tendencies can be related with other studies, where according to Yusuf, the study showed the highest percentage of heavy metals removal for lead was obtained at 12, and the lowest percentage was obtained at 3 gram. In general, the proportion of heavy metal removed from treated pineapple peel increased as the adsorbent dosage was increased. As for the conclusion, this work proved that the use of agricultural waste material such as pineapple peel as bioabsorbent are highly efficient for the treatment of heavy metals due to its porosity and the presence of multifunctional groups on material surface. Last but not least, the bioabsorbent characteristic and the bioabsorption potential on different conditions, especially pH and dosage, should be considered since it can affect the rate and percentage of heavy metals removal.